In this video, we will explore how you can create a mobile joystick input for your game to have it playable on mobile devices. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. In my project, right now I have a character that can move using my keyboard arrows. I can jump using spacebar and use control to attack. And that's what I want to map to a mobile input. Before we start, if you want to learn more about visual aspects of working with Unity and about shaders and visual effects, check out Jetelli YouTube channel, the link will be in the description. To add the mobile input for my game, I will use Kenney assets on-screen controls, the link will be in the description of this video. Okay, this is my project. I have imported the assets and I will be using those flat dark icons. First of all, I want to start by creating a canvas. Now I have my player and my player prefab has its own UI because its UI is only concerning this player. So I will use this prefab to create here my canvas. So I will open my player, right click, UI, add a canvas, and I will call it mobile input canvas. Okay, we need to take into consideration how we are going to scale all those elements. What we can choose is constant pixel size or the two remaining scale with screen size or constant physical size. Now, I would consider constant physical size as well as the scale with screen size. Here is the example of constant physical size for the 2K screen, but if we select a lower resolution, the controls will be too big. Now, if I swap it in my settings to be scale with screen size, this might be perfectly fine, but for a bigger resolution, those controls might be very small. But I will go with this option. So we're going to set the canvas scaler to be scale with screen size, and I will set 1920 by 1080 to be the resolution that I aim for. When we have this, let's add to our mobile input canvas, right-click UI and select a panel. So this will be our panel that will represent our joystick. We are going to open the RectTransform settings in the inspector for this panel. I'm going to select this anchor preset. I'm going to hold Shift and Alt to set the pivot and the position to be the bottom left corner. Now I will set the width and height to be 300 by 300. And in our scene view, we should see our panel. Now I will want to offset it a bit since I have already some UI here. Now, of course, for the mobile version of your game, you might want to modify the existing UI. So what I will do is I will simply move it away from the existing UI. So let's set the position on X to be 200 in the inspector and position Y to be 30, for example. And we are going to close the RectTransform and open our image. I want to set the color to be full alpha so that I can see the image, and I will select the background source to be from my flat dark folder. It will be flat dark 06. Okay, and we should see our circular image that will represent our joystick. Of course, this will be the background of our joystick. Now, we will need to also have the inner part that will actually move. Let's rename the panel to be joystick panel, and we are going to add, right click, and we are going to select UI image, and this will be our joystick inner part, so this will be what moves. Now again, I will select the RectTransform first, and I will select the anchor preset, hold Alt and Shift, and I will set it to be in the center of this joystick panel. Now for the image, I will select flat dark 00, and you should see that in our scene view we have this image of our joystick. I will go to the inspector and set the width to be 175 and height to be 175, and this will be our joystick that we are going to use. Now, to use our joystick, we will need to have a custom script. So let's go to a folder. For example, I will go to my extra assets, right click, create a C# script. I will call it mobile joystick. And let's open this script up. Great. Now what I will do is paste some variables to our script. So instead of update and start, we are going to have a private RectTransform reference joystick transform. Now, since our UI uses the rect transform instead of the transform, we want to simply save the rect transform reference, since if we access transform, it will be the default transform, and I want to have rect transform reference saved here. Next, we are going to have a serialized field private float drag threshold. Now, this will be the threshold which will tell me if I want to accept this input to be passed down to my character to move in this direction or not. I will clamp my inputs to be 0 to 1 or from -1 to 1, just like the default input does it, so that we know that if the value is greater than 0.6, this means that the user wants to move in this direction. Next, we are going to have a drag movement distance. Now this will be the distance that our joystick moves around on our screen. And we are going to have a serialized field private int drag offset distance. This will be used to convert the distance between where we have is the center of our joystick and where our user touched the screen. It will be much more clear when we start creating the methods that use those values. And last thing that we will have is public event action vector to on move. This will be a delegate, so I will use it to inform other scripts that actually we have some input to use to move our player. First of all, I will create an awake method that will get the joystick transform. It will be equal to rect transform, so that we are going to upcast the transform to be the rect transform. So we are going to use it later on in the calculations. One thing that we are going to need is to know when our player is dragging our UI joystick. So we are going to use IDragHandler from the Unity Engine event system library, and this will allow us to get information about the event of our UI element being dragged. We are going to also use onPointerUp to know when our user has let go of the joystick, so we can reset our position of the joystick as well as stop the movement of our player. So at the top, we are going to add using Unity Engine.event system, and this will allow us to add here after monoBehavior a comma, and let's type IPointerUpHandler. This is one of the interfaces, and we are going to add IDragHandler. Now those interfaces are contracts that require us to implement a specific method to our mobile joystick class. So right click, quick actions, and implement interface, and on the IDragHandler the same, quick actions, implement interface. And this will add to our script public void onDrag and public void onPointerUp. And now this argument contains all the information about the pointer, like its position. So basically it is all the information that we might need to do something in our onDrag and onPointerUp event. Now if we go to Unity, we will see that our joystick is in position x0 and y0. So this is our default position. If we change the position on x, we can see that it moves around. If we do the same on Y or on both of those, we are going to have again this kind of movement, which we want to use to inform our player that we are actually using this joystick. Now, if we let go of our joystick, we want to go back to this position. And that is why we have this reference to our joystick transform, because in our onPointerUp, we will have two things: joystick transform anchored position. So this is the position X and position Y that I have shown you in the inspector. We are going to simply set it to be vector to 0, so the joystick is back in its original position. And we are going to call onMovement?.invoke vector to 0, so that we are going to send to a movement script that we are using for our character or whatever we have that we do not want to move again. So this will inform my character movement script that I want to stop the movement. Now, what happens in on drag, so when we are dragging our component, our UI element? Well, if we go back to our Unity, basically what we are going to do is drag this element in different directions. And right now, we can get the position of our pointer, so of our touch from our touch screen of our mouse. But the issue is that we are working with our input in the screen space. So the screen space is what we see on our device, and the 0, 0 is in the bottom left corner, and the top right corner is the width and height of our screen, so this will be the resolution. Now, whatever this value is, if we get the reference to this position here and get the reference to our position where our currently the pointer is, so when we are clicking, so basically we can compare the center position of this joystick and the position when the joystick currently is to calculate the direction in which we want to move. Now, this seems simple enough, but actually the calculations can be rather complex. So we are going to calculate the position where we have clicked and calculate it in reference to the center position of this object. So we are going to assume that we are working with this coordinate system where the 0, 0 is the center of this joystick, and when we click we are going to get the distance or the offset from the 0, 0 to this point, and this will be much easier for us to calculate the direction in which we want to drag our joystick and in which we want to move our player. So on drag we are going to have a bit of code. We are going to have a vector to offset, and as I have mentioned, we are going to calculate the reference of the position where we have clicked. So this is event data position, which contains the screen's position where we have clicked our mouse or where we are currently touching our finger on the screen. And we are going to use RectTransform screen point to local point in rectangle. Now, this is a pretty confusing name, so what it does is calculates the local position inside our joystick transform using this event data position, so using the input position where we are clicking, and this outputs this offset. You can check out more about RectTransforMUtility from the documentation. Here is our screen point to local point, and all it does is helps us to calculate the coordinate in the local space of the rect transform that we pass here. So just to verify what we have done, let's debug.log here our offset. And let's save the script. Let's go back to Unity. Great. I will add our new script, so mobile joystick script, to our joystick, the image of our joystick. So if I now press play, we are going to see that if I click on in our game and drag our mouse up, holding our joystick, we are going to have those X 7.6 and Y 331. If I drag to the right, we are going to have other values, like on the X-axis we are going to have 600 and so on. So this should work correctly. We have the offset from the center point of our joystick in the direction that we are dragging our mouse. Now, those are pretty big values, and I know that my joystick panel only has width and height of 300. So if I want to ensure that my joystick doesn't move further than this, in this direction, I will want to divide this value by, for example, 100 or 150. So if I divide it by 150 and make sure that my joystick moves from 0 to 1 depending on this value, so from 0 to 300, we are going to only move the joystick this much and it will stop moving. So basically, in our script, this is the drag offset distance value. So this will limit the movement range of our joystick. So we are going to use this to divide our offset by this value. And if you want to get the value from 0 to 1, as I have said, to know how far should we move our joystick, so what we are going to do is calculate offset equals vector to clamp magnitude. We are going to clamp the offset vector using our drag offset distance. So the magnitude, so the length of the vector can be greater than 100. We are going to divide it by 100 to normalize it to be in range from -1 to 1. And this is exactly what we get if we get our input.getAxis. So let's save it. Let's see how we have this value is right now. Okay, let me press play in Unity, and we are going to see now that if we drag our joystick, we are going to get those values between -1 and 1, and those should be correctly set. 1, -1, -1, and 1 in all of those directions. Now, second thing that I want to mention is if we drag in the diagonal direction, we're going to have the 0707 because of we are clamping the magnitude. So basically what I want to do is I want to set the threshold So when we are dragging up and the second value is 0.5, so this is less than 0.6, I want to only accept the vector up as the input, and I'm going to discard the y value. This is only because of how my game works. So this is in turn the private float drag threshold. This will be the value that will limit which value do I take for my character movement. Okay, but first what we can already do is we can move our joystick. So not only we can debug.log this value, we are going to use it. We're going to set joystick transform.anchoredPosition equals offset times the drag movement distance. So this is the value 30. Let's save it and let's see how it works. So I'm going to stop the game and play it again. Okay, I'm back in Unity. I have pressed play again, and now our joystick should be moving together with our pointer. Now if we let go, there will be one issue, that it doesn't move back to its place. Okay? And the problem is that the I pointer up handler only will work if we have also the I pointer down handler, and we need to add this. Let's quick actions and implement the interface. It will add to our script the on pointer down method, but I have nothing to add here because we are not going to use this method. But now if we save it and go back to Unity and press play again, we will see that our joystick will get reset to its original position. As you can see, I have added the debug.log on pointer up. So again, I'm going to go back to our script, and last thing that I want to do is calculate the movement input. I will create vector2 input vector, and I will call calculate movement input from this offset. I'll right click on this method, quick actions and generate it, call onMove (.invoke), and I will pass the input vector. Again, as I have already mentioned, I will have the code that limits when we register the input depending on the drag threshold. So if the value is greater than 0.6, I will accept it as valid x and y. So float x equals math abs, so absolute value of offset x. If this is greater than the drag threshold, we are going to keep this value, else we are going to set it to 0, and we are going to calculate the same way the y value, and I'm going to return it. And this is how I will inform my agent that I want it to move. I'm going to call this onMove (.invoke input vector). Okay, I will need to have another script, so I will right click, create a C# script, and I will call it my player mobile input. And let's open this script up. Great. Now in my game, I have defined a iAgent input interface that, if I implement, gives me all the methods that my player input needs to pass to an agent so that it can perform some tasks. And I need to now assign this movement vector to get the reference to or to get informed by our mobile joystick method that we have that we want to move. So what I will do is I will add here a method, or actually a field and a method. So we are going to have a serialized field private mobile joystick, and we are going to assign it through the inspector, and we are going to call private void start, and on start we are going to assign to our joystick onMove event a method from this script, so we can set our movement vector and call our onMovement action event. So I will right click, quick actions and generate this. You might have something different in your code, but basically to make my character move, all I need to do is set my movement vector to be this input vector, and I need to add here private set so that I can set it, and I'm going to call onMovement (.invoke movement vector). I will save this. Great, now my player already has the player input that uses the keyboard and mouse input. I will remove this, and I will drag here my player mobile input, and I will assign the joystick. Now if I press play, my character should be moving using our joystick. Now I will try using this on my connected Android device using the Unity remote, and as you can see now, I can run using my joystick. Now if we want to assign some functionality to a button, all you need to do is select your canvas, select UI, add a button, and I will select one of the other sprites from my icons. Let's select, for example, this one. I'll assign it to the button image. Let me expand it. Okay, here is our button. Okay, let's select this B, set native size, and I will select this button. I will place it, anchor it in the bottom right corner of my screen. I will set its size to be 150 and 150, and I will set the position to be -50 and position on Y to be 50. Here is my button, and now we can use the button on-click event to assign some functionality to it. Now in my player mobile script, I have added two methods, jump pressed and jump released, since I am taking into account how long the player holds the jump button and when they release this button, and I have appropriate event actions here. So I need to have two events on my button, not only the click, but also the event when I let go of the button. Okay, back in Unity, what we could do is use this button on click event if we have only one event, but instead we can even remove this component altogether and add what is called EventTrigger. An event trigger allows us to add any event that we want to listen to. So I'm going to add pointer down, and I'm going to add pointer up. And I want to add to both of those a listener. I will assign our player, and I will choose mobile input. On player pointer down, I want to call jump pressed, and on pointer up, I want to select jump released. And now if I press play, I should be able to press this button and be able to jump. So if I switch to my phone, I can now traverse my game and look out for the enemies, because I have no weapon or no way to use my weapon. But now all the input should work fine. Great! I hope it gave you some idea how you can implement the mobile input UI for your game. If you want to learn more about this 2D platformer game, check out my Unity 2D platformer video course about learning how to use design patterns in your code. Thanks a lot for watching. See you in the next video.